Hello, everyone. Nice to see you all. Hi, Josh.
Hello, Kat. Nice to see everyone.
That's nice to see everyone. Let's get this started, shall we?
Sounds good.
Hang on a sec. I'll get the slides going and we'll learn about climate change. Hang on. Mrs. Geary, you're not the only one having technical issues. Just please bear with me. There we go. That's more like it. Right. Thank you so much, everyone, for joining us today. It's Climate Action Week, and we're so excited to see all of you. I was trying to keep up with all the hello messages in the chat, and there are so many, and it's just amazing that you've all taken the time out of your busy school days to learn with us today. So thank you so much. So there's lots happening this week. It is Scotland's Climate Week, as you may know, and this is a global event which in Scotland takes place this whole week with loads of activities encouraging climate action across the whole country. But it's also the Great Big Green Week. And that is a celebration across the UK of action on climate change. And it takes place from last Saturday until this Sunday, the 2nd. And in Scotland, there's going to be more than 1,000 different events taking place. So it might be worth having a look and see what's going on near you. Right, so a wee reminder, a year ago, you might remember an event called COP26 taking place in Glasgow. And that was a whole lot of world leaders getting together to talk about what can be done about climate change in cooperation between all the different countries in the world. This happens every year. And last year, we were lucky enough to host it in Glasgow. This year, it is in Sharm el-Sheikh in Egypt. And in addition to that, there is also the running out of time relay race happening between Scotland and Egypt. It's a record-breaking 7,000-kilometer non-stop relay between Scotland and Egypt to deliver a message on climate action to the world's leaders at COP27. And it takes place this coming Friday, the 30th of September to the Sunday, the 6th of November. You can get involved by signing the pledge on our website and taking part in their Global Schools Day, which comes in November, which is a great follow-up activity to what we'll be doing this week. So what will we be learning this week? We've got a whole lot of really interesting lessons for you this week. Today, we're going to learn all about what is causing our planet to warm up so that we can understand the problem. Tuesday, we're going to look at the impact or the footprint that we create on our planet and how we can change this for the better. And then on Wednesday, we're going to learn from nature to bring solutions and clever technology. On Thursday, we'll look at the wonderful work that people are doing to help our natural world recover. And on Friday, we have a celebration of the whole week with your work, a very special guest, and live coverage from the Running Out of Relay race in Glasgow Green. And what would we like you to do as part of your climate action? There's 3 things, and we'll remind you of them after Josh's lesson. But first, we would like your school to go out and do a litter pick because we cannot allow all the litter that's outside to keep harming our wildlife. Next, we'd like you to try something called craftivism. Craftivism is like crafty activism. It's a gentle way of protesting or campaigning, mixing arts and crafts with bringing positive messages and raising awareness. And we would like you to become inspired by the amazing collage work from wildlife artist Paul Bartlett, whose work you can see just there on the screen with those lovely puffin mosaics or collages. And as a class, we would like you to create a poster that depicts a native Scottish species that's being affected by climate change, like these puffins. Puffins are my favorite, so I really like these pictures. Your poster should have a message to grown-ups about climate change, about what you want to happen. The winning class will get a prize of a virtual tour for either the Edinburgh Zoo or Highland Wildlife Park, and a wildlife camera trap for your school. If you don't know what that is, a camera trap is a camera that you hide outside and it takes pictures of wildlife when they come to visit your school grounds. Very cool piece of kit. And the third thing you can do is the pledge that I mentioned earlier. On our website, there is a pledge to become a climate action school and take action through our education programs and campaigns, which you can see listed across the bottom there. We've got Eco Schools, our new program, Leaf Young Reporters, Climate Ready Classrooms, One Planet Picnic, Upstream Battle, Dandelion, and Pocket Garden. So when we're done here today, if you want to have a good look at that and sign our pledge, that would be amazing. And now I would love to introduce you to my colleague, Josh, who's going to teach us all about what is happening to our planet so we can understand the problem. Take it away, Josh.
Brilliant. Thanks so much, Kat. Yeah, so if you can stop your share and then
Yes, I
will
will.
be able to share.
That would help, wouldn't it?
Yeah, so
There we go.
morning, everyone. My name's Josh, and I'm going to be talking to you today about climate change. And I'm going to begin by asking you a question, or two questions really, and I want you to have a go at answering those questions in the chat for me. So what we're going to be talking about today is we're going to be talking about what's happening to the planet at the moment, and then we're going to be moving on to thinking about climate change and something called the greenhouse effect, which you may or may not have heard of before. But what I want you to do first is just to have a few ideas and then put some answers in the chat. So what do you think is happening to our planet at the moment? Or another way of thinking about that could be, what should we be trying to fix? So are there any problems that you can think of in our planet, in our environment, that you think we should be trying to fix at the moment? And I'd love to see some of your answers. So I'm going to give you a few minutes to have a bit of a chat as a class, maybe put some hands up for your teacher and see, what do you think we should be trying to do to help fix some problems with our planet at the moment? I'm seeing lots of lovely answers already. So many wonderful answers. I can't actually keep up with all of them. Really, really wonderful. So lots of nice answers, as I said, coming through. And these answers are kind of falling into a few categories which I've got. So this is our planet, and you could describe it as maybe not being as happy as it could be at the moment. And that could be due to a few problems, just like the ones that I'm seeing coming through on the chat now. So we've had some people talk about plastic pollution or plastic waste. We've also seen something in the chat about using too many fossil fuels and the gases that they release into the atmosphere, which we're going to be learning a bit about later. And we've also got things like that using those fossil fuels causing something called climate change, which is what we're going to be focusing on later in today's session. And some other people have spoken about kind of using our natural resources a bit too much. So maybe overfishing, maybe catching too many fish in our oceans. Lots of people have spoken about melting ice and how melting land ice can cause our sea levels to rise. We've also got things like consuming lots and lots and lots of stuff, and that leading to us making loads of waste, lots of kind of rubbish, which, as Kat mentioned, hopefully you're going to go on a litter pick and try and combat some of this. And we've also had lots of things about deforestation, chopping down trees, and wildfires and things like that. And that's really, really It's a really comprehensive list of lots of answers. So it's really lovely to see that you're so well informed and all of this. And what we'd actually like to see is we'd like to see our planet a bit more like this. And that means that we're working in harmony with nature, and we've got more use of renewable energy resources. So things like wind turbines, solar power, and also working together to try and solve some of these problems and looking after our natural resources, looking after our wildlife, looking after our animals, and thinking more about trying to consume less stuff and therefore generate less waste, less rubbish, and less pollution. But if we go back to this slide here, I've got a question for you now. What do you think links all of these things together? So just like you've done really wonderfully already, I'd like to see some answers in the chat. All of these things around our planet that are making it unhappy, what thing or things do you think could link all of these together? So I'm seeing lots of lovely answers coming in. I'm wondering if you've all seen my presentation already, because you're all getting the answer that I was looking for. Yeah, so lots of lovely answers coming in, and you're all kind of basically saying very, very similar things. And the most common answer that is coming up is humans. And not only do we have a great chance to have positive impacts on our planet, we also need to recognize that we can actually also have negative impacts on our planet. And it's once we realize that, it's about thinking about what we can do to try and turn those negative impacts and try and have a bit more of a positive impact, because we are linked to all of these things happening. And like I said, the one that we're going to be focusing on today is this one. Okay, so we're going to be focusing on climate change. And just another question for me now, our climate is our long-term weather. So it's like our weather over a period of at least 30 years. So how do you think our climate is changing? What do you think? What have you noticed about how our climate, how our long-term weather has been changing? So just like you've been doing again so wonderfully, give me some answers in the chat. How do you think our climate in the UK, in Scotland, how do you think our climate is changing? Really nice. Lots of really good answers, some very high level answers coming in as well, which is really lovely to see. So we've got things from becoming more extreme weather happening. So we've got ice melt, more storms, we've got potentially more floods. We've got things saying heavier rainstorms. We're saying it's getting wetter. I notice that it's getting wetter in the sky, so more rainfall. And another common thing that's coming up is that it is getting warmer. And that is true. So the last summer that we had, so the summer that's just been, we had our hottest day that we've ever had on record. So Scotland was 35.1 degrees in July this summer. And that's the hottest day that we've had on record. So we can see that our climate is changing and it is getting warmer. And it's getting warmer because of something called the greenhouse effect. And I'm just going to very quickly explain what the greenhouse effect is. So here is our planet. And around it, we've got our atmosphere. And that's where our gases are. Now, you may not have heard of the word gases, but things like oxygen, which we breathe in to help us survive, and carbon dioxide, which plants take in to help them survive, those are all found in our atmosphere. And there's some other gases that we find in our atmosphere, which we're going to be learning a bit about later. And then we've got space, and then that yellow ball up in the top left, that is our sun. And our sun sends light and heat down to us. So that big yellowy orange arrow, that represents all of the heat and light, coming from the sun. And it hits our Earth and it warms our Earth up. And that Earth, our Earth, then sends some of that heat back out into space. So we've got a nice big red arrow of some of the heat then going back out into space. But some of that heat ends up hitting something called greenhouse gases, which you may or may not have heard about. But greenhouse gases basically work a bit like a greenhouse. And what they do is the heat which leaves the Earth, it hits those greenhouse gases. They take in that heat and then they send it straight back down to Earth again. And that causes the Earth to warm up a second time. So it's warming up the first time from the heat coming directly from the sun, and that's that yellow arrow. And then some of the heat leaves, it goes straight back out into space. Some of it goes back out and it hits the greenhouse gases in our atmosphere. And then those gases send it back down to Earth and they cause Earth to warm up a second time. And that is the greenhouse effect. It's a bit like how a greenhouse works. Now, we do actually need the greenhouse effect to help keep our temperature of our planet fairly stable. And there's somewhere really near to Earth, which doesn't have an atmosphere and therefore doesn't have the greenhouse effect. And you might be able to see it if you look out of the window at the moment. You'll definitely be able to see it if you look out later on tonight, if it's not cloudy. And what I'm talking about is our moon. So our moon doesn't have an atmosphere, and it doesn't also therefore have a greenhouse effect. And that is one of the reasons why astronauts, when they go to the moon, is one of the reasons why they need to wear these special suits. So these suits, not only do these suits give our astronauts oxygen to help them breathe, but it also helps protect them against the temperature changes on the moon. So when it's daytime on the moon's about 100 degrees, okay? And so we would instantly disappear. We'd burn straight away if we were exposed to the moon at that temperature. And at nighttime, the moon's about minus 130 degrees. So that's about 7 times as cold as your freezer at home. So to put that into context, if we were to take an egg to the moon, in daytime, the egg would cook in less than a second. And in nighttime, the egg would freeze in also less than a second. And it's because the moon doesn't have this greenhouse effect, keeping it at a nice stable temperature, that this would happen. And so the greenhouse effect is an important thing for us to have because it helps keep us stay at a nice stable temperature. And we can actually model the greenhouse effect. And your teachers are going to have resources to do this. And you can do it later, but I'm just going to show you how you can do it now. So at some point later on, you're going to get 2 glasses and you're going to fill them using a measuring jug with water, and you're going to fill them with the same amount of water each. And these glasses, they represent our Earth. And what you're going to do then is you're going to take a thermometer and you're going to measure the temperature of each glass of water. And on one of the glasses of water, you're going to take could be a sandwich bag, a freezer bag, and you're going to pop it over the glass, just like this. And this bag represents our greenhouse gases. So it's going to cause the greenhouse effect to our Earth, which is the glass. And you're going to leave both of these glasses, you're going to leave them in somewhere which gets direct sunlight. And you're going to leave them for at least an hour, hopefully a few more if you can. And then you're going to come back and using the thermometer, you're going to measure the temperature of them. And I've got 3 questions that I want you to think about when you're measuring the temperature of them. And you don't need to answer them now, but these are just for you to think about. The first one is, what's going to happen to the temperature of the water? So what's going to happen to the temperature of the water in those glasses when you leave them out in the sunlight? Next question, will there be a difference in the temperature between those 2 glasses? So do you think the bag over the glass, do you think that glass will be warmer or colder than the glass without the bag? And finally, what do you think would happen if we added even more bags to this glass? So we've got this one on top of it. What would happen to the temperature if we added even more? Now, these questions, they've been popped in the resources folder that your teachers have. So you can have a think about them and then have a go at answering them when you do this experiment. So adding more bags to the glass, that's a bit like this other thing, which is called global warming. I'm very quickly going to explain that before I've got an activity for you all to do. Okay, so you'll recognize this picture from before. So we've got our sun. It's sending down some light and some heat to the Earth. The Earth is then sending some straight back out into space. Some of that heat ends up hitting greenhouse gases and ends up coming straight back down to Earth and heating it a second time. Now, with global warming, we can have more greenhouse gases in our atmosphere, and that means that we then have more heat going back down to Earth. So when we burn things like fossil fuels, we release these greenhouse gases, and as we put more of them into the atmosphere, we then have more of them sending heat back down to Earth, and it causes our Earth to warm up more. So global warming is making our greenhouse effect stronger. So what we're going to do now is we're actually going to look at these greenhouse gases and the differences between them. And I've got 2 activities for you to take part in to do that. And I'm going to need some help from Kat to help me demonstrate this.
Hiya.
So she's going to appear here. Brilliant. And some of you may also want to do this at the same time. Some of you may want to do it later, but if you want to do it at the same time now, then you can mirror it with Kat. So what I'm going to do is I'm going to introduce some of the greenhouse gases and you're going to have to do something. So the first greenhouse gas that we've got is CO2, also called carbon dioxide. So CO2 is the short name, carbon dioxide is the long name. Now, it's not very good at warming, so it's not very thick, but we've got lots of it into the atmosphere. And so Kat is going to have to put on 4 layers of CO2. She's going to have to do it as quick as she can. And if you're trying to do it along the same time as Kat, you've got to be as quick as you can. So we've got 4 layers of this greenhouse gas CO2 in our atmosphere. There's 1, there's 2. You're doing an excellent job, Kat. I wonder if anyone is managing to beat you at this speed. So you've got to put on 4 layers.
One more.
Of CO2. So 4 layers of carbon dioxide. Excellent. How are you feeling, Kat? What's your temperature like?
All right. It's a little bulky, but a little bit warmer.
Excellent. Okay, well, I've got some bad news for you, Kat. Unfortunately, we have got more greenhouse gases out there.
Oh,
and
no.
I know. And what I'm going to ask you to put on now is our next greenhouse gas, which is methane. So methane, we don't have as much of it as CO2, but it's a bit warmer. It's a bit better at warming us up. So Kat is now going to have to put on 3 layers of methane.
Oh, these have sleeves.
Yeah, they've got sleeves, so they're warming her much more. And Kat is I didn't say this at the start, but Kat is representing our Earth in this example, okay? So Kat is planet Earth. She's home, and she's now putting on 3 layers of
a bit more difficult, Josh.
methane. Yeah, it looks like it looks like it's getting a bit trickier.
Yeah.
So not only has she got 4 layers of CO2 in the atmosphere, she's now also got 3 layers of methane or CH4 in her atmosphere. How are you feeling now, Kat?
I'm getting a bit uncomfortable, actually, Josh.
Yeah, it's looking a bit toastier. Now, I wish I could say that was it, but unfortunately, no, we've got a bit more to go. So the next gas that Kat is going to have to put on is nitrous oxide. Now, nitrous oxide, we've got a bit less of that than methane, but it's even warmer than methane. It's even better at trapping heat. So Kat's going to have to put on, unfortunately, 2 layers of nitrous oxide.
Oh, no.
I'm really sorry, Kat. I'm really sorry about this.
1.
So 2 layers of nitrous oxide.
Oh, goodness.
You were looking incredibly toasty, Kat.
Oh, yeah.
So the fancy name for nitrous oxide is N2O. How are you feeling now, Kat? You're looking pretty uncomfortable, I'd say.
A bit sweaty.
Yeah, a bit sweaty, a bit too warm.
Very warm.
Well, Kat, unfortunately, I'm really sorry again, but you've got 1 more greenhouse gas to put on now. And this greenhouse gas, we've only got 1 layer of it for this demonstration.
Oh, good.
But unfortunately, it is the best greenhouse gas at keeping things warm that there is. So it's the strongest greenhouse gas there is out there. And it's got 2 names. We used to call it CFCs, and we sometimes now call it F gases. And there's only 1 layer of it, but it's really, really, really warm. Oh my word. How are you feeling now?
It's got a hood as well.
It's got a hood as well. If I was to get you to do a lap of the office that we're in at the moment, Kat, how do you think you'd feel?
Oh, I don't think that would be very comfortable at all. I'm very, very hot.
Yeah, I can see that. And hopefully some of you have managed to follow us along with Kat as well. And this represents the greenhouse effect and global warming. Okay, so we're putting too many of these greenhouse gases into our atmosphere, and they are making our planet, which is Kat in this example, far too hot. Thank you so much, Kat. You can now take those layers off. You can cool down. If you've been doing this along with us, really well done. I hope you got some lovely images of you doing that. You can take those layers off, and we're going to move on to our next activity. So we've learned about those greenhouse gases, but what we need to think about now is, where are those greenhouse gases coming from? So what I'm actually going to do now is I'm going to slowly reveal some images to you. And whilst I'm revealing those images, you need to have a guess in the chat what you think those images are. And those images are sources of greenhouse gases. So the first gas that Kat put on was carbon dioxide. So that's the full name. The kind of fancy science name is down at the bottom, and that is CO2. So you may have heard of that. So carbon dioxide, also known as CO2. there's 2 slides coming up now, and each slide has got 2 images on, and you need to have a guess in the chat what you think those images are. So here's our first one. So I'm going to remove the first block. Any guesses in the chat for what do you think these sources of CO2 are? Anyone guess what sources of CO2? There's 2 of them in this picture. Going to slowly reveal a bit more. Yep, getting some really lovely answers. You're very good at this game. It does get a bit trickier later on. But yeah, so I've seen things written down like vehicles, cars, planes, which are the 2 images, and fossil fuels as well. And cars and planes, they run on fossil fuels. So they run on oil or something that we get from oil. So it could be petrol or diesel. And when we burn that to help our cars and planes move, we then release CO2 into the atmosphere. Really brilliant. Lots of really good answers there. So there's some sources of CO2. CO2 doesn't just come from that, though. I've got another 2 images. This is a bit trickier. So what do you think these 2 images are? So there's 2 images. I'll do another reveal. Really lovely answers coming through. You're very good. You're very good. You're all exactly bang on. Yeah. So the photo on the right is a pylon, and that's moving electricity. And it's not the pylon itself, but it's actually making electricity. So we can make electricity again by burning fossil fuels. The main one we burn is gas. So natural gas we can burn, and that generates electricity for us, which is really useful for us. But downside of that is that it releases CO2 into the atmosphere. And we've also got radiators, which heat our homes. And the main way that most of us, not all of us, but the main way that most of us in Scotland heat our radiators is by burning natural gas again to heat up water. And that again is really useful for us because it keeps us warm, but it does release CO2 into the atmosphere. Okay, brilliant. Well done. So the next gas that Kat put on was methane, or the fancy science name for that is CH4. And there's 2 photos now of sources of methane. So what do you think is in this image here? Going to reveal the first one. So 2 things that look a bit like ears to me. So there's 2 animals in that picture. Excellent. Well done. You all know your animal ears very well. It is some cows and some sheep. Now, this isn't about demonizing them. This isn't about saying they're bad or awful. It's just about recognizing that they do release the greenhouse gases. And it mainly comes out the front end, okay? But cows and sheep do release methane, more so than other animals. Now, I've got another image here. This is a bit trickier. So there's another source of methane. So what do you think this image is? Well done. Lots of food wastes coming in. That's really good. Now, I do need to be clear with this one. So some people have written composting, and composting is actually really, really good. What I'm representing with this photo, though, is throwing food away into general rubbish or into the general bin or into general waste. I'm not thinking about putting food in a food waste bin or composting it. Doing those two things is really good. What I'm talking about here is either throwing your lunch away into a general bin, you know, it could be at school, it could be on the street, or it could be in a park, but putting food in general rubbish means that that food could end up in a tip. And when food is in a landfill site or in a tip, it can then, when it breaks down, cause methane to be released. If food's been put into a food waste bin or composted, that's a really good thing to do with food waste. But if you put it into a general rubbish bin, like you might have the black bins that you have around where you live, or in the park or at school, then that can cause methane to be released, which we want to avoid. Brilliant answers. Okay, the next gas that we had is nitrous oxide, and the fancy name for that is N2O. And this is a bit trickier, this image is, I think. So what do you think this photo is representing? A very small section of it here. Yeah, you're all very, very, very close. So what I've got here is a photo of the tractor, and it's not the tractor itself. It's not the crops that the tractor is helping grow. It's what's happening at the very back of the tractor, which is releasing the greenhouse gas. And again, this isn't about saying about demonizing this or saying this is a bad thing, but it's about us recognizing that greenhouse gases are linked to these activities. And this tractor is adding fertilizer to help the crops grow. And fertilizer helps help crops grow. But a downside of using fertilizer is that you get nitrous oxide being released. So if you're growing crops and you're using fertilizer, a downside of using it could be that we could have extra nitrous oxide going into the atmosphere and acting as a greenhouse gas. Now, the final one, okay, so we've got F gases. They used to be called CFCs, and so people kind of use these names at the same time, but we tend to now call them F gases. And this is the final image, and this is potentially the trickiest. This image is a very fancy version of the thing that I'm thinking about. It's much fancier than the one that I have at home. I wouldn't dare show you a photo of the one that I have at home. There's a bit more. Excellent. So what we're thinking here is fridges. So this is the most common source of F gases that we'll probably see in our day-to-day life, and that's fridges. And some fridges use F gases to help keep our food cool. And again, that's a really useful thing. But if we damage our fridges, if we break those fridges, then that can cause some greenhouse gases to be released. And it's a really good reason for making sure that we look after them as much as we can and stop them becoming damaged or broken. Excellent, really well done. Excellent answers there. So we've seen a few obvious ways that greenhouse gases are linked to our lives, but there's a few other ways which maybe aren't quite as clear. So we're going to look at some greenhouse gases linked to things that we do or things that we own. And again, this isn't about me telling you what you should or shouldn't be doing. It's just so you're aware of how greenhouse gases are linked to our lives, because they're linked to our lives in lots of obvious ways, but some ways which aren't very obvious as well. So what I want to do now is this image here. We've got some trainers, okay? And to make our trainers, we may use some leather. We may also use some cotton, and we may also, well, they'll have to be made and transported around. So my final question for you today, I notice we've only got 5 minutes left, so I'm going to be wrapping up soon. But my final question for you today is, what do you think is going into, or what greenhouse gases could be linked to either making the leather, to growing the plants, or to making or transporting the shoes around? So any greenhouse gas guesses that could be linked to those three things? Brilliant. Some really lovely answers, and you're all bang on. So for the leather, that'll come from a cow, so we could have methane there. The cotton, it's collected from a plant that we grow. If we use fertilizers to grow it, then we could have some nitrous oxide. And if we're making and transporting the shoes, that's going to use energy, and that could mean that we get some carbon dioxide being released from generating that energy. Another example that I'm going to show you before I say my final thing and hand over to Kat is our phones. Okay, so we need to make our phones. We need to manufacture them that can use energy. Our phones use electricity, and they also store data. When we make our phones, we use energy, so there's going to be some CO2 released from making them. If we burn fossil fuels to make the electricity that our phones run on, then there's also going to be some CO2 there. And all of the data that our phones have, so the photos, the images, the messages, they all need to be stored on massive computers called data centers. And those data centers need to use electricity to run, and they need to be kept cool. And so again, we've got CO2 being linked to that as well. And this isn't, again, about me telling you what you should or shouldn't be doing, but it's about knowing how greenhouse gases are linked to things that we own and things that we do. And we call all of these gases that are linked to our lives our carbon footprint. And that's what my colleague is going to be talking to you about later on next week. That's all from me. Thank you very much for taking part. The rest of the week, we're going to be thinking about all of the positive things that you can be doing to help combat climate change. And I'm going to stop sharing now, and I'm going to hand over back to Kat just for the final few words of the session. So there we go, Kat, it's all yours.
Thanks, Josh. That was amazing. I feel much more comfortable now that I've taken all those layers off, though. Right. Just to quickly run over two things or before we say goodbye for today. First of all, if you have any questions about today's lesson, please send them to us at ecoschools@keepscotlandbeautiful.org, and we will share the answers to those questions at our assembly on Friday. And on Friday, we're hoping to have a special guest. We're expecting that First Minister Nicola Sturgeon will be able to join us briefly at our assembly. So keep your fingers crossed that that all works out for us. And also, we'd love for you to say hello and share your work on social media or by email. Show us your experiments, and please share the answers to the questions in the experiment with us and see if you were right, because we would love to know if you were, how you did with that. And I just wanted to say that the questions for the experiment will be in the folder with all the resources very shortly for your teachers to have a look at those. So thank you so much for joining us, and we'll see you again tomorrow.